Thank you everyone for coming for this session. I'm going to be talking to you about how do you do BI on Azure HDInsight using HDInsight interactive query, which was generally available this week. So in this session, I'll be talking to you about some basics of how do you do BI on Hadoop, some of the challenges that customers see as moving from traditional warehousing systems to a sort of a big data-based system for doing a BI-based scenario. And we'll take a look at a demo of interactive query on how you can do interactive query over Hadoop using a Hive on LLAP. So, fundamentally, customers require these three sort of pivots where they want to interact with their data, they want to interact with the data at scale, and they want to have a high concurrency in terms of number of queries that can run in the system. It should be easy to use, it should be secure by default, so customers should be able to use their Active Directory credentials. The data should be secured from a ACL perspective on which user can have access to what data, and it should be easy to manage, and it should be cheap. Like if you shouldn't have to pay for high cost for querying of the data. And if you look at how sort of the evolution of the warehousing industry has happened, and especially towards big data, like what has happened in historical implementation is the entire process needs an SLA for a DW solution to exist for an end user. And the two bottlenecks that were observed was one at the ETL front and one at the reporting front, where as data volume was getting bigger and bigger, the existing systems were not able to scale to the size of the data, and the queries that were running in the system were too big. So the industry kind of evolved to sort of these MPP offerings, which were trying to solve this problem of sort of doing massive parallelized computing at scale. And while they were sort of parallelizing it, more and more data was coming in, and the kind of queries customers started running, or the kind of workloads customers started running, started to evolve as well. It was much more than sort of writing a SQL query, and it became like, I want to do analytics on the same data set. I want to use Spark. I want to use open source libraries. So the desire for having a big data system kind of evolved because of these offloading kind of requirements that came up from the data and from the requirements of the customers. Like customers wanted to do more analytical like workloads along with doing BI on top of the data as well, which led to the evolution of BI going sort of towards a big data direction, and sort of Hadoop came along as a platform which separated compute and storage, came with HDFS and sort of massive computing powers. The problem still remains, however, on how do you get a high concurrency system running so you can have multiple queries running on the system as well. And if you look at the fundamental building blocks of building a petabyte scale DW on Azure, here are some of the tenets that you have to think about. It's a data lake with no limits, so it's a data lake that keeps on growing. You might start off with a few gigs, you might go to a few terabytes, petabytes, but it's growing on a day-to-day basis. You have rich ingestion options to bring a variety of data from a variety of sources. You could be bringing in streaming data, or you could be bringing in data from other data sources, and you can do sort of ETL on the data set in the data lake itself. So you don't have to move the data to a different data source for ETL. Once you're done with your ETL operation, you should be able to sort of interactively query that data set. So you shouldn't have to, and within a sub-millisecond or a sub-second, you should get responses for those queries as well. And then eventually, you should be able to connect these queries or results to a BI solution or a visualization solution. Like you can connect it to Power BI, and if you can broaden it up, you can have APIs, you can connect to Tableau, and more tools available in the Azure ecosystem as well. And then the whole system has to be secure in terms of which user has access to the environment, and what user privileges are existing for the data that they can access. So in terms of tables, in terms of columns, in terms of rows, or in terms of the data set. And some of the information that's stored in the data set itself should be secure, like PII-based data, or if you're storing credit card information. So that should not be exposed to the user. And what we'll look at in this example is how do you, what are some of the pros and cons of moving data at this scale. Uh, you know, the pros are you can sort of reuse what you have, uh, but the cons are that you have to maintain schemas across different systems. Data offloading takes time, especially at a petabyte scale. You have challenges on how do you keep both data sources and the data uh, uh, the source and the destination in sync. And then it's just an operational nightmare in terms of moving, petabytes of data from one system to the other. So that kind of led to this Hive on LLAP solution, which allows you to interactively query over data, which can sit in Data Lake Store or Azure Blob Storage. So you can do interactive query over that data itself. Here are some examples of performance benchmark run on a Hive interactive query cluster. So this is Hive on Tez and interactive query, and you can see the tremendous improvement that has happened for interactive query over the period of time. This slide talks about total time it took for a 1 terabyte data set to run all the 99 queries of TPC-DS, and you can see a 4x improvement by using Hive on LLAP. So I'm going to show you a quick demo on what does a typical query look like in terms of running it on a Hive LLAP cluster. So what you're seeing over here is this is a cluster that I have. It's probably has about 100 terabytes of data. And I'm going to execute this query over here. And if I switch over to my monitoring view, which is the Tez view, you will see that this query is going to be submitted to the cluster. And then I'll get the results back over here. So that's one example of how you can sort of interactively query. You can write the same query in Visual Studio Code, which is a cross-platform editor for developers. So I'm on a Mac machine. I'm using Visual Studio Code. And you can submit a cluster, submit a job from this environment itself. So by selecting this cluster, you can submit a job to the interactive query cluster. You can also connect Power BI to the same cluster for interactive query. So in this example, what I'm showing you is I have a Power BI which is using direct query, which means that it's going to query directly over the data which is sitting in the data lake itself. So there is no data movement involved. So as I click around, the first click is going to be a query to the engine, which is Hive LLAP, and you'll get the results back. And then the results will be cached in the query engine itself. So the next time when you run the same query, you'll get the results from the cache. And if you sort of start clicking around, you'll see these cache results are coming back fairly quickly, which sort of tells you that over a terabyte of 100 terabyte data set, you can interact with your data fairly quickly. You can add in more dimensions in terms of the filters you want to apply to your data set, and you can get those results very easily back to your sort of visualization tool. So this experience is a fairly rich experience in terms of how you can do interactive query over a big data set. So here are some results of doing interactive query, which is at a sort of a petabyte scale. This is an architectural diagram of what does the cluster look like. A key point that I wanted to make was what happens if your data changes? Then how does cache eviction happen? In this case, the cache is evicted, and you get sort of the fresh data always when you query. And it supports a variety of file formats. So again, if you're running multiple workloads in your data lake, so you might be storing different file formats like OR, Parquet, JSON, Avro. The key thing over here is it supports all these formats, so you don't have to do ETL operations to change the data format from one to the other for BI scenarios. You can just query over the data in terms of whatever format it has, and it could be structured data, it could be unstructured data. It should, so it works on all these form factors. So I have these slides that will talk about how the performance looks like. But you can run these performance benchmarks on your own. So this is a URL where you can download these scripts. But And you can even do more concurrent queries over the data set as well. I think you can do about 60 plus concurrent requests over the query itself. And it's supported by a rich ecosystem, so you can use your rich BI tools, you can do Excel, you can do Zeppelin, and you can connect it easily to the interactive query cluster. So this is one way how you can do BI on top of HDInsight on a petabyte scale, so without having any data movement, and you can interactively query over that data set. So I hope you like this presentation. Thank you for your time.